There are different ways that we can express domains. One of those is interval notation, another is set builder notation. And I'm recording this video now, right when we are switching from using WebAssign for online homework to using MyOpenMath. I don't know if we'll be with MyOpenMath forever, but at least at the moment with MyOpenMath, I've seen that all of the problems, I think, want interval notation. So I wanted to record a short video where I show you interval notation for different domains, just so that there's no confusion. In some of the example videos I've made, I use set builder notation, which it is what it is. I recorded those videos a while ago, but I want to just go through interval notation now so that everyone is on board. So in the previous video, we looked at some examples of functions and their domains. I actually want to start with g of x equals the square root of x plus 3. I think this is the simplest one. In the video, we figured out that the domain was the set of numbers x such that x is greater than or equal to 3. And so if you were to graph that on the number line, and I'm just going to draw a very quick sketch here, x is greater than or equal to 3 means that we're shading to the right of 3. These are the numbers that are greater than 3. But also we're including 3. And if we want to write that in interval notation, an interval is when you have all of the points in between two places on the number line all included. This interval starts at 3 on the left, so we can write 3 and then comma, and as we go to the right, it goes all the way to infinity, goes infinitely far, so we would write 3 comma infinity. And then we have to say whether or not 3 is included. In this case, x could be greater than or equal to 3, so we have a closed circle. But there are situations where we might want to refer to the interval that doesn't include 3. Now, if we do include the endpoint, we use a bracket. So we're going to put a bracket next to that 3. And when we have infinity as an endpoint, we always use a parenthesis. A parenthesis means that we're not including that endpoint. And this is a little bit of a special case because infinity is not a real number. It's just an idea. And since we want our solutions to be numbers and not ideas, we do not include infinity. And so we use a parenthesis. If we were to have the interval that has an open circle there for some reason, from 3 onwards, in that case, we would put parentheses, 3 comma infinity. If we wanted to have a closed circle but shade to the left, that is the interval that goes from negative infinity on the left to 3 on the right. We've got a parenthesis with infinity and negative infinity always. And because we've got a closed circle, because we include the 3, that's going to be a bracket. Similarly, if we had an open circle on the 3 and we were shading to the left, that would be parenthesis, negative infinity, comma, 3, parenthesis. And in MyOpenMath, you can put 2 lowercase letter O's, and that turns into the infinity symbol if you need to. All right, so that's one of the examples that we saw. Another example that we saw was h of x equals 3x squared minus 5x plus 1/2. And for this one, we saw the domain was x such that x is a real number, or we could say all real numbers. And in that case, if we wanted to graph that on the number line, well, all real numbers is just the whole number line. Any number on the number line can be a solution. And so in interval notation there, we would say this is the interval that goes all the way from negative infinity on the left to positive infinity on the right. And we always have parentheses when we're dealing with infinities. And so that would be the interval notation for this one. The other example we looked at, f of x equals 1 over x minus 2, ends up being just a little bit more complicated. The domain here was the set of numbers x such that x is not equal to 2. If we wanted to graph that on the number line, then we would basically be shading in everything except 2. So we'd be shading to the right of 2 and to the left of 2, but not 2 itself. So we could put an open circle at 2. And this ends up being a little bit different with interval notation because there's actually 2 intervals. This open circle cuts the number line into the left side and the right side. And so in a situation like this, we write out each of those intervals. The one on the left goes from negative infinity to 2, but we use a parenthesis because it doesn't include 2. And then the interval on the right goes from 2 to infinity, again with a parenthesis. And we put a symbol in the middle that looks kind of like the letter U, but it's not. There's no little tail off to the side. It is not actually the letter U. It is a mathematical symbol that looks like this. And that symbol is the union symbol, meaning that our solution is what we get when we take both of these intervals and add them together into one larger set. Now, frustratingly for me, in MyOpenMath, if you want to trigger the union symbol, you do have to put a capital U. It frustrates me to no end, but unfortunately I do not control MyOpenMath, so we'll just have to deal with it. It is free, so we are saving money by putting in the letter U, even though I don't like it. But anyways, these are the different ways that we can express the domains of the different functions that we're dealing with. It's always going to be either a number or infinity on the left and right with a comma in the middle, and then either brackets or parentheses on the side, depending on whether or not the number is included, if it's an open circle or a closed circle. And then if we have multiple intervals, we need to use the union symbol in between. I hope you've all seen this before at some point, and this is just a bit of review. I hope that it ends up not being too difficult on the homework, but if anyone is struggling, you can always ask questions. Let's get any issues sorted sooner rather than later, so we're all good moving forward.